Hi everyone, welcome back to Coding with Bharat channel. So this weekend, we had a Leetcode weekly contest that I wanted to discuss. So yeah, let's get started into it with the first problem. So the first problem is known as Harshad number. So the problem said that a number is said to be this special type of Harshad number if I take the sum of its digits, right? So for example, if I have 25, sum of its digits is 2 plus 5, which is 7. So if this sum of its digits is divisible by x, right? So the number itself is dividing this sum of its digits, then it is known as a Harshad number, right? So as an example, 18, x is 18, so 1 plus 8 is 9. So 18, if you see, the number x is divisible by this sum. So the sum is 9. So 18 is definitely a Harshad number. So sum of the digits should be dividing the actual number. Okay. Similarly, x equal to 23, if we look, 3 plus 2 is 5. Does 23 divisible by 7? Answer is no. So answer is minus 1. Whereas here the output was sum of its numbers. So it basically says return the sum of the digits, return the sum of the digits if x is this kind of a Harshad number, otherwise return minus 1. So here it is a Harshad number 18, so I'm returning the sum, which is 9. 23, it is not a Harshad number, so I'm returning a minus 1. Okay. So if you talk about what we need to do in this question, you will clearly see that we need somehow to get the sum of its digits. Okay. So let's talk about how generally we can get some numbers, some of the digits of a number. So if we have any number x, let's say 125, right? So we need to get each individual digit one by one. So for example, here, first I would need to get this one, then this two, then this five, and so on and so forth. So if you think about it, there is an operation which can let us easily get one of this digit, which is the units place digit, by just doing a modulo with 10. So as soon as I find the remainder, when I divide this 125 with 10, I'm going to get the units place number, which is 5. Right? Now what I can do, I can go about dividing this number by 10. So x by 10 would give me 12. Like integer division, right? Not the actual division, but integer division. So x by 10 will give me 12. Similarly, next, again, if I do 12 modulo 10, I'll get 2, which is the next digit. And again do 12 by 10, which is 1. Lastly, also again do 1 modulo 10, I get 1, and do 1 by 10, which I'll make it to 0. So keep on taking the last digit out by doing modulo 10, and then keep on dividing by 10 to reduce the number one by one, like removing one of the digits from the end. So that is how we can actually get the entire number with us. Another simple way, if you don't want to do this, convert this into string. So there is a function s2i, that is for string to integer actually, but a toString function, which is to convert an integer to string in most of the languages, and then go one by one through the each digit of the string and add it up, right? That could also be one of the possible ways you can go about it. But this pattern is common, where we keep on dividing the numbers by 10 and keep on taking modulo with 10. Okay. So yeah, that is what I have written in the code form as well. So if you look at the digit sum function, what I've done, I have initialized my sum as 0. Then till the time x doesn't become 0. So I'll keep on dividing till the time x doesn't become 0. Add the remainder with 10 and divide by 10. So keep on dividing by 10 and adding the remainder by 10 into my sum and return this sum. So this function will give me the sum of the digits of any given number x. So what I've done, I have got this sum into my element y, and now I've checked if x divides y perfectly. So how do we check that? Using modulo. So if x modulo y is not equal to 0, that means it doesn't divide, I'll return minus 1, otherwise I'll return y. So that was the simple idea of solving this first problem. If you talk about time complexity, then these steps each time divide the number by 10. So the complexity would be number of digits, which is also equivalent to log base 10 x, that number of maximum power of 10 till which the number goes. Okay, so yeah, that is what the solution is all about, and if we submit it, you'll see that we also get it as accepted. Cool then. So that was the idea of the first problem. Let's discuss the second problem in the next video.